I'd like to look at question 2 on this mock exam, and as before, first I'll go through and explain the correct answers, and in a separate video I'll discuss how you might grade this particular question. As I go through it, I'm going to explain orally the reasoning I would use, and then I'll show you someone else's solution and kind of match what I said and what they said up together, I hope. Always start by reading the question and seeing what you've got, and I would recommend doing things like this as you read through it, where you've underlined normal distributions and you've got some stuff. Read with a pencil in your hand as you go through it. And so the first question says, approximately what percent of all U.S. adults have systolic blood pressure greater than 142? So this table is about these 29 people. The stuff I've underlined in green is about all U.S. adults, so all I need is that stuff in green. I've got a normal distribution with a mean of 122, a standard deviation of 20, and I want to know what percent is above 142. So I've got to show my work where I'm standardizing that 142 and finding the probability that I end up in this region of that normal graph. And so here is one way to show the work. You've got the mean and the standard deviation. They've written the formula, and they used their calculator where they clearly noted the parameters in the calculator and got that answer. Of course, you could use your chart for that. The way I would probably recommend is more like this, where we've standardized and shown that we've got this standardized value here, and this should say 142 minus 122 over 20. And either way, we get a similar thing. They allowed you to use the chart or the calculator or the 6895-99.7 rule. Any of that is acceptable. For part B, it says describe the distribution of blood pressure for the 29 employees who were sampled. So using this chart right here, describe the distribution. Now, if you think about it, when we talked about describing the distribution, we either talked about cussing it or putting on your socks. Either acronym works out to be the same thing with the center, the unusual observations, the shape, and the spread. So the center is either going to be the mean or the median. Since these two numbers are so close to each other, it's reasonable to think the graph is approximately symmetric because the mean and the median are so close to each other. The spread, I could either talk about the standard deviation being this, I could talk about the IQR being a measure of spread. I suppose I could talk about the complete range being a measure of spread. I either personally like the standard deviation or the IQR. And then we need to talk about unusual observations or outliers. And what I would do is use Tukey's 1.5 rule. So I'd find IQR, multiply it by 1.5, subtract it from Q1, add it to Q3, and see if any numbers fall outside of that range. If I look at IQR right here, it's about 30 times 1.5, that's 45. 45 more than this, way over the max. 45 less than this, way under the max. I don't see any unusual observations. So let's check this out. The shape, roughly symmetric because the mean and the median are essentially equal. The center is about 140. The spread, they listed either one, just like I mentioned. And then they showed some work on determining whether or not there were outliers. I probably would beef this last sentence here up and say, since no points fall outside this range here, which I think is what they're trying to do with these inequality symbols. Letter C. The CEO wants to know if the mean systolic blood pressure of employees at her company is higher than the national average. State the hypotheses for testing this concern. Note it doesn't say do the whole test, just state the hypotheses. So I know that the national average is 122. This is important. I do not know the average at her company. What I know is the average of these 29 randomly selected people from her company. So what I want to know is the true mu, which represents the mean of employees at this company greater than 122. So my null hypothesis is that it's equal to 122. My alternative is that it's greater than 122. That would be written like this, and don't forget to define your terms. Letter D. The conditions were met, so they did a hypothesis test. They got a t statistic of 5.495 and a really small p-value. Interpret this p-value in context. What would this p-value lead you to conclude? Well, the second half of that, since the p is low, I'm going to reject HO. I'm going to decide that this is not true and that their blood pressure actually is higher. The interpretation is this. If I did this sampling over and over and over again from a population whose mean was 122, this is how often I would get an answer like 139 or more extreme. So that's pretty unlikely. Usually when the answer is 122, I don't get answers like 139. Let's see what this says. Assuming the mean really is 122, the probability is that of getting 29 employees who had 139 or more. This is basically impossible, really unlikely. So we have convincing evidence or statistically significant evidence that I should reject HO and decide the mean is greater. Letter E, explain in context what it would mean to make a type 2 error for what we did in these previous parts. Okay, so a type 1 error, this is what I like to refer to. A type 1 error is rejecting HO when it's true. And that helps me figure out what a type 2 error is. A type 2 error is the other error, so I must have continued to believe HO when it was false. So I've continued to believe HO, I've continued to believe this, but I ought to reject that because this is false. So I've continued to believe that the average blood pressure at this company is just like the rest of the country, when in fact it's actually higher at this company. Deciding not to reject the null and saying that the mean blood pressure is not over 22 when in fact it is greater than 22. Ooh, look at all this. Now don't get overwhelmed with this. They've given me some data, kind of skimmed through this, linear regression, some different, there's a residual plot, some different stuff, summary statistics. Interpret the slope of the regression line in this context. Okay, so I've got to figure out what is the slope. I can look at this and get an idea that the slope is something positive. I could even get an idea of what it might be by sort of estimating how much the y went up over, say, this range. So if I kind of figured out from here to here, the y went from here to here, and kind of making a fraction with the change in y over the change in x. But really, all I need to look at is this number right here. That is the slope. That's the slope. So what that tells me is every time x goes up by 1, y goes up by this. Now this is a prediction model, so I would say it's something more like this. Every time x goes up by x goes up by 1, I predict y is going to go up by about this amount. It goes up because this is a positive number. So put in context, for each additional age, I expect the systolic blood pressure to go up by an average of 0.9493. Let's see what they wrote here. 9493. For each additional year of age, the model predicts an increase in systolic blood pressure of 0.9493. Units are a great idea. Grammar is only graded insofar as you've communicated your point. They're not grading your grammar, but if your grammar is so awkward they can't understand what you're saying, that would be problematic. Give me just a second. Let's look at some other stuff here. This is the y-intercept, or the predicted y-intercept. This is the standard deviation of the residuals. This is r squared. To find r, you could simply square root that, and then you'd have to worry about whether it was positive or negative based on this. These things over here, those are not part of your curriculum this year. That's one of the chapters that we skipped this time. This is a residual plot. The key word here is whether or not there's a pattern. I'm looking for a pattern here, and I don't really know that I see one. Looks like the line does a little bit better job down here than it does over here, because these points are closer to the line, and over here I have more spread, but I don't necessarily see a pattern. So that's this part. The next part, comment on the strength, direction, and form of the relationship. Okay. Looking at this graph, looks linear. It's positive. It's also positive because my slope was positive. And the strength is related to this 0.712. I could, in fact, square root that if I wanted to. And either way, I'm getting the idea that the line is moderately strong. If I square root that, it's about 0.84. So it's a moderately strong, positive, linear relationship between these two variables. Strong, positive, linear relationship between these two variables. And then they actually explained them here. It's strong, what they're looking at on each case, and that's probably a good idea to write down as well. I don't know. Yeah, I like this. This is good. So let's finish this video, and then I'll show you a different one on how you would grade this question.